Okay, so should we wait for 2 more minutes until some more people join and then we can get started? So, just to recall what happened in the last session, I think towards the end of the last session, we decided that we'll solve a few questions on deterministic finite automata and regular languages this time, that is in today's class. So I asked students to kind of populate a Excel sheet with the questions, and I think one person has done that. I have collected the questions. We'll be solving that today, and going forward, I think because the manpower in Gate CSE is very less, I am the only student assigned here. Maybe I thought it is a good idea if we cover engineering mathematics here. So going forward, I'm planning to start with linear algebra because what I feel is for GATE core subjects, right? You have lot of resources online. Uh, Engineering mathematics is something that when I was preparing for GATE, I was kind of felt it difficult. Yes, Ashikant. Today we'll discuss finite automata, but going forward, I'm my thought. What I am thinking is perhaps it will be worthwhile for you guys if I cover engineering mathematics because uh, the material available online is kind of very contrived. Yeah, so I thought maybe that will help you. But for today, as we discussed last week, we'll solve finite automata and regular expression questions. Okay, so I'll start. I'll share my screen and let's get started. Yes, Ashkan, thank you. I think you shared a website with the questions, right? We'll be solving the same questions now. Yeah. And one request from me is when I am kind of solving the questions, right? It may be difficult for me to monitor the chat messages. I request you to unmute yourself and ask any question that you have. Okay? Yeah. I'm sharing my screen. Somebody has a doubt. Yeah, why don't you unmute and ask it? Hemalata. Yes, Hemalata, you can ask your doubt. Is it possible to crack gate in 5 months? Yes, it is possible, but you have to spend at least 12 to 13 hours every day, and you should practice previous year questions and also, yeah, it is difficult, but definitely possible if you are totally determined. Okay, so let me go to the questions. Sorry, wait, where is it? Sorry, this is not the sheet. So, Shashikant has shared a couple of questions on finite automata. The questions are really good. Thank you for solving. I mean, sharing those questions. Uh, but let me make one confession. Uh, I have studied TOC, and in 2017, when I attempted GATE, that was one of the strongest subject uh, with respect to my preparation. After 2017, I never had a chance to revisit TOC again. So yesterday, when I solved the questions, sorry, not yesterday, today, I could remember the concepts, but most of the questions I committed silly mistakes, right? So I would take this opportunity to reinforce to you that you may have like I may have a strong grip in the subject, but for us to be able to crack gate, practice is what matters, right? unless you take a pen paper and solve questions and practice them, we are prone to committing a lot of silly mistakes. So yeah, I encourage all of you, like after this class also, if you let's say you learn something out of this class, I encourage you to take questions from previous year gate and solve it yourself. Okay. Yeah, this is kind of disturbing. So so uh, do you think it is a good protocol that I follow? Like until 6:10 I will admit students, but after that we'll ignore. Okay, is it a good idea? Because it is kind of disturbing for me to like swap tabs and admit on the yeah. So until 16 I will admit, and after that we'll freeze the class. Okay. Yeah. So these are the questions. The first question, what they're asking is, they have given us a couple of regular expressions, and for these regular expressions, we should draw the deterministic finite automata. Right. This is the first question. I think this kind of questions you must be already familiar with. Now, second question, what they're asking is, they have given us a set of languages, and they're asking us to show that these languages are not regular. Now, to prove that a language is not regular, the tool that we use is called as pumping lemma. Right. In second question, we'll see what pumping lemma is, how we can employ pumping lemma to prove these languages are not regular. Right. And third question is also kind of same. Here they are explicitly telling us that you should use pumping lemma to show that the following languages are not regular. Now, what I am planning is I'll solve ABCD, and the questions ABC in this section will be homework problems for you. Okay, so we'll learn pumping lemma. We'll see how to employ them and solve each of these questions. After this, these three questions you will take it as homework. Okay. Now, next question. What they are telling us, they have given us some languages that are complements of a original language. Right. In this question, you should draw DFA for original language. Now, as part of this question, I'll teach you what a complement language is and how to construct a DFA for a complement language. And perhaps I will solve two of these eight or seven questions. The remaining questions you will take it as homework. Now, similarly, for the next question, they are asking us to construct intersection of two languages. Here again, I will show you how to construct intersection DFA and perhaps solve two questions here. Remaining questions you will take it as homework. Again, I insist that after class you solve these questions using homework. Otherwise, whatever you learn in this class you will forget easily. Yeah, somebody had a question. Okay. Should we get started with solving the questions?
Yes, sir.
Yeah. So, is my screen visible to everybody?
Yes, sir, it is visible.
Yeah. And is my writing legible?
Yes,
Yeah,
sir.
yeah. Okay. So we'll get started. So as I told, the first question, they have given us a couple of languages and they are asking us to construct DFA. Now, what is a DFA? It is called deterministic finite automata. Right. Now, let us see some semantics of a DFA. A DFA always has a start state.
Um, Excuse me, I have a request. I mean, if you can, record this session and upload it to some YouTube channel, something like that, so that we can access at that later stage.
Okay. So I am recording the session already. After this, I will post it in my YouTube channel.
Okay, thank you.
Yeah. So a DFA will have something called a start state, right? Then in this language, in any language, we have something called symbols. Now, for example, in these three languages, the symbols are 0, 1, right? So every DFA will have a start state, right? These states we represent as nodes in the DFA graph, right? From each node, you should define what are called transitions, right? From every node in a DFA, you should definitely define transitions for each symbol in your language, for 0, for 1, right? and every transition will take you to a new state. Uh, and one more thing you should remember is these transitions can also be self state. Like you can take a transition with the symbol 0 comma 1, and you can go to the same state. That is also allowed, right? And there is a designated node called as end state. End state you will denote by double walled circle, and a start state you will denote with a node that has an incoming arrow, and that incoming arrow will not have any other it will not have any node here, right? These are the semantics of a DFA. Now let us construct a DFA for let's start with a simple language to understand what a DFA is. Then we will see AB, and perhaps I'll give 5 minutes for you to solve C. So in the future classes, I request all of you to sit with a pen and paper so that you solve some exercise real time in the class. Okay. So now the first question, let's take a simple question. Let's draw a DFA for the language 0 plus 1 the whole star. Sorry, I think we should not use set braces here. We should use uh, 0 plus 1 the whole star. Now, can somebody unmute and tell me what are the languages that are what are the strings that are accepted in this language? Somebody?
Sir, 0, 1, then
Yes,
0, 0,
0,
0, 1,
1, correct.
1,
0,
0,
0,
0,
0, 1,
0,
etc.
1.
All
Yes,
possible strings, right?
yes, sir.
All possible strings. Now, one thing you should notice is I have 0 plus 1 within bracket and I have a star here. Star means 0
So,
or
so there is a question: is the order matter like 0, 1 or 1, 0 two different things?
sorry, order in which I have written this set. You are asking that?
Yeah, I mean, no, this
Ah,
is like 0 plus 1. So, I mean, we can
no. So yeah, good
0,
question.
1 or 1, 0 when
Yes, when I
it will be
have
treated differently, or
yes, that's a good question. Uh, when I have 0 plus 1, plus means or. What
okay,
this? Okay, so there are some symbols we need to understand some symbols. Now star means 0 or more character. Plus means one or more character.
okay,
Right now, plus means or. Or what does or say? Within this bracket, you can choose either 0 or 1, right? And you can repeat this action of choosing 0 or 1, 0 or many times, right? Now
so
let us
there
see.
is here order doesn't matter. I mean, we can choose 1, 0 or 0, 1,
You
whatever.
can choose any because this or is kind of or does not insist any order, right?
Okay,
I'll immediately next I'll give you an example where order matters.
okay,
Okay,
thank you.
in this question order does not matter. Fine. Now what this expression is saying us, take. So let us see this expression, unwield this expression one at a time. Now you have this expression in within bracket. It is sorry. So I'm using blue pen now. Uh, what this is? Let us take this expression one at a time. Within bracket, I'm going to write in English what this expression means. 0 plus 1. 0 plus 1. What it is saying us is take 0 or 1. This is what 0 plus 1 says. Now let us see what it means to what it means for 0 plus 1 the whole star, the total expression. So what does star mean? You will take the action 0 or more times.
Yes, there is a epsilon and otherwise.
Exactly. So when you enumerated the language, you missed epsilon here. We should have epsilon also. Why? Because we have a star here. Star means you can repeat the action 0 or more times. When you
Okay,
repeat the action 0 times, you get epsilon. When you repeat the action 1 times, you will get 0 or 1. When you repeat the action 2 times, you will get 0, 0, 0, 1, 1, 0, 1, 1. Right? Now let us see, like one more language, 0 plus 1, the whole, 1, the whole plus. What does plus mean? Plus means one or more times, right? When you have plus, then epsilon cannot be part of the language because you need to take the action, repeat the action of taking 1 or 0 one or of taking 1 or 0, this action one or many times, right? So I repeat, for 0 plus 1 the whole plus, the language will be 0 1 0 0 0 1 1 0 1 1, etc. Got it? Now one of you asked a question, does order matter? Now let me give one more language. Let's call it 0 1.
Sir,
Yeah, what's the question?
sir, what is the difference between star and plus, sir?
So star means you can repeat the action 0 or more times, meaning you can it is fine if you don't know, if you do not take this action also. That is why when I say 0 plus 1 the whole star, and if you take the action 0 times, which means you're not doing anything at all, that is why you have epsilon as part of the language,
Okay, sir.
right? But plus means you definitely should take action one or more times. Because you need to take action one or more times, epsilon is not part of your strings that encompasses the language.
Okay, sir.
Yeah. Now earlier there was a question, does order matter? Now to answer that question, I am giving you one more language here, 0 1 the whole star. Right? When I say 0 1, you can think there is a hidden operator dot here. Earlier I told 0 plus 1, where 0 and 1 I separated using an operator plus, but in general for dot we generally do not dot is, can be thought of as concatenation operator. But in general we kind of do not have this concatenation operator. You can, that operator is hidden. Okay, so the language is 0 1 the whole star. Now here order matters, right? What this language translates to is, the action is take symbols 0 1. You should, if you take a 0, immediately you should take a 1, and this action you can repeat 0 or more times. Now can somebody tell me what are the languages admitted, sorry, what are the strings that are admitted by the language 0 1 the whole star?
Then it will be epsilon,
Epsilon
0 1,
701
0 1, then
0 1 0 1.
very good.
010.
Yeah, you got the thing right. So these are the kind of things where order matters. When you have a plus, order does not matter. You can either take the symbols to the left of plus or to the right of plus. Now let us see how to construct a DFA. We will start with a simple question. Let us see how to construct DFA for 0 plus 1 the whole star. Now as I said earlier, every DFA will start with a starting state, and from each state you should definitely have arrows corresponding to every symbol in the language, right? I should have an arrow for 0, I should have an arrow for 1.
So I have a question here.
Yes.
I mean, this is a start state, and there are two symbols, A and 1. Sorry, 0 and 1.
Yes.
Right. But there is a start, a start arrow there also. So can we? I mean, I have seen questions like when we get 0 or 1 through that arrow as well.
Oh no, you cannot, to the starting state you cannot have 0 or 1. That is not allowed.
Okay.
That is not allowed. But like somebody follows a convention, so I follow the convention of having a arrow without a predecessor, like there is no predecessor here, right? I follow the convention of having an arrow without predecessor to denote the start state. Some I think some other textbooks may follow different conventions, I'm not aware, but this is standard. We always denote a start state with an incoming arrow, and to this incoming arrow we do not have a predecessor node.
Now, suppose if the initial state is a accept state, then
Yeah, we'll come to that. We'll come to that. Yes. Now, so what I'm doing is to follow the convention of a DFA. What I told you, will always have a start state, and if you have a node in a DFA, you should always define transitions with respect to every symbol in the language. And one more thing I told you was, all the ending state you will denote with double walled circles. Right now, for this language 0 plus 1 the whole star, the acceptable strings are almost everything, right? epsilon 0, 1, 0, 1, etc., etc. Almost all possible strings are accepted by this DFA. Right? Now, on 0, will you go to a start state or ending state?
I will get ending statement.
Ending state, exactly. So you see a 0 and you will go to ending state. Now, from the ending state, when you see a 0, will you go to start state or ending state?
Again, the ending state.
Ending state, right? You see a 0, you will go to ending state. Again, if you see a 1, you will go to ending state.
Yeah.
And similarly, for this 1 also, you will go to ending state. On seeing 0, you will go to ending state, or on seeing 1, you will go to ending state. And because this DFA also accepts empty string, you don't have to see anything to go to ending state.
Can we have same ending state for both the 0 and 1?
I'm coming to that. But are people convinced that this is a valid DFA for the question? So what this DFA is saying is, you do not see anything, still you will go to ending state. You see a 0, you will go to ending state. From 0, if you see one more 0, you will go to ending state. Or if you see a 1, you will go to ending state. Similarly, if from the beginning, let's say you consumed a 1, you will go to ending state, and you literally see anything, you go to ending state. Right? Now, I think our friend asked a very good question. Why do we need, these 3 different ending states for this DFA? Can I simply write this DFA as this one? And on seeing a 0 or 1, I'll go to the ending state only. Do you have doubts when I say that the DFA that I drew on the left and the DFA that I drew on the right are equivalent? So what I really did here, I told you that you have a state, from every state you need to define transitions, and when I followed the algorithm of defining a state, defining transitions, I ended up with a DFA that kind of gave me like every state to be a final state. Now what I'm saying, this DFA can be compressed into this simple DFA with just one node. Do you have questions as to why this DFA is?
I have a different question because in the first graph,
Yes.
if I have only one accept state, suppose if we have 0 and 1 simultaneously, then I think it will not be DFA, it will be an FA, because there will be 2 moves from start state to.
Sorry, which graph? This graph you are saying this graph is not a DFA.
First graph.
Okay. Why is it not a DFA?
No, it's a DFA, but I was asking that suppose we can have only single accept state. We move 0 or 1 for both transition for the accept state.
Sorry, I could not follow this question. If I give,
you in the graph you made 2 accept states. What I was saying that.
That's right. Yes.
So it will be an FA because then there will be.
That's right. Correct. So one thing is every DFA can have only one start state and only one ending state. A DFA should have only one start state and one end state. Fine. So what do I mean by this statement? Even if you construct a DFA that has many states like this, many states like the one that I drew on left, you can always convert this DFA into a valid DFA that has just one start state.
Sir, I have a confusion here.
Yes.
Every DFA has only one accept state or only one transition for a particular level.
So for every by DFA by definition, from a state, if you a transition with respect to a symbol of the language will deterministically take you to the next state. Sorry, I think I retract my statement. A DFA can have more end states. Sorry.
Yeah, that's what I'm saying.
But it should have only one start state, and it can have many end states.
Many end states, but the transition will be definite. I mean,
transitions will be definite. If transition is kind of non-deterministic, we call it as NFA.
Yeah.
Right. and you have a theorem that says that every NFA has a corresponding DFA. Fine. Sorry for the confusion. I think every in a DFA you can have, I repeat. So in a DFA you should have only one start state, but you can have many end states. I think in that sense, then this must be a valid DFA. Sorry, this is a valid DFA, but this DFA has another equivalent simple DFA that has only one end state. Is it all right?
Yes, sir.
Yeah. Actually, sorry, I got totally confused. So in this set of questions only, we'll see that yes, for question A, we'll see that we definitely need two end states. I think we cannot construct a DFA for question A with one end state. We'll see why. Okay.
Yeah, because there are two, different set of
Correct.
things.
Correct. Yeah. Then I think I was wrong with the statement that every DFA with multiple end states can be converted to one end state. So sorry for the confusion. Totally sorry. So a DFA can admit many end states. Okay. So now we saw one simple question. Now let us see another simple question. Can somebody draw DFA for 0 plus 1 the whole plus? Can one of you unmute and tell me? I'll keep drawing as you say. So I'll start with the start state. Now on is start state an end state?
No, sir.
No. Now on seeing the 0, you will go to end state, or
Yes, sir.
you
End
will go to
state.
end state. On seeing a 1, will you go to end state?
Yes, sir.
Yes. On end state, on seeing a 0 or 1, what will you do?
Sir, on the end state.
End state 0 comma 1. So this is a DFA because you have, again I repeat, you have one
At
start
least two
state,
states for that.
one start state, and one end state. And more importantly, for every state in the DFA, you have transitions defined for every symbol in your language. From every node, for every symbol, you should define a transition. All right. So now let's go to the question. Let me add a page. Okay. Yes. Now the first question is 0, 0, 0 star plus 1, 1, 1 star the whole star. So A I will solve, B you will solve it real time, C you will take it as homework. Okay.
So there is a question, sir, and in the first graph, I feel it can't be, correct for 0 plus 1 star because, there is no epsilon transition for the first graph.
Yes, that is why start state is not an end state, right?
Yeah, I mean, the second graph which you have created is actually the real graph of 0 plus 1 star, whole star, because the first graph don't have any epsilon transition. So,
No. This is the DFA for 0 plus 1 the whole star. This is the DFA for 0 plus 1 the whole star. This is the DFA for 0 plus 1 the whole plus.
I am asking for, first graph which you created where there
Yes.
are two end states.
This one.
Yeah.
Oh, you are saying this is not a DFA for 0 plus 1 the whole plus. Sorry, whole star.
Yeah. Yeah, because there is no epsilon transition here.
Yes, so here you have start state, right? That is the end state, so it will accept
Yeah,
epsilon.
there is a three end states here.
You have
Then
three end
only.
states, yes. Why is this not a DFA?
No, it's a DFA. I'm saying that until there is a three end state, you can't have 0 plus 1 star. It's a 0 1 plus 1 plus.
No. This my claim. Okay, let me draw the DFA again here. What I'm claiming is this DFA is also a valid DFA for the language 0 plus 1 the whole star.
But initially you made two end states for 0 and 1. But in the state of it, when the first state is end state, then only you can have epsilon transition.
Correct. Yeah. We definitely need the first state to be end state. Yes. Otherwise, it will not accept epsilon. But nevertheless, this is a valid DFA. But this kind of having more states than required. Okay. Let me admit some students. Okay. Now, do people have doubts with the question? Do others have doubt? Okay.
No.
So now let's go to the question. I'll solve this question, and the next question you will take it as homework. I mean, you will solve it yourself right now. The first question is 0 0 0 star plus 1 1 1 star the whole star. Now let us see each symbol at a time. What is this guy saying? You should at least accept 2 or
3.
more zeros.
Okay.
2 or more zeros. Similarly, what is this string saying? You should accept 2 or more ones. Is this clear?
Yes, sir.
Yeah. Now let us see this this action. This action translates to either accepting 2 or more zeros or accepting 2 or more ones. You can either take one or either let me call this as action A. Let me call this as action A, and let me call this as action B. What this guy is saying means you should either take action A or action B. And now let me analyze the total expression. What this guy is saying is you can either take action A or action B. This action you can repeat 0 or more times. So is there any doubt in the way that I interpret this regular expression? I hope that's
No.
okay. Now,
Yes.
yeah. So now let me go to the solution. So first thing that is very easy to observe here is this repeat 0, which means we already know that epsilon is part of the language represented by this regular expression, which means I can immediately start with a start state being end state. Right? Now I have two actions, action A or action B. Action A tells 2 or more zeros, action B tells 2 or more ones. Right? Now let me represent that action immediately. You take a 0, you go to intermediate state. Again you take a 0, you go to intermediate state. And the second action is you take a 1, you go to intermediate state. And you take a 1, you again go to intermediate state. Now, because this is a star expression, you can either take action 0 or action 1, 1 or 0 or more times. So I have encoded 0 times here. Taking action A one time corresponds to this state being the final state. Right? And taking action B one time corresponds to this state being a final state. Now, roughly I have got the skeleton of my DFA. Right? I have a start state, I have some end states. Now what is missing is I told you that with respect to every node you should have a transition defined with respect to every symbol in the language. Now let us fill the missing transitions. Now when you see a 0 and if you see a 1, is that a legal string in this language?
No.
No, right? So I know that if I have a 0 followed by a 1, I should immediately go to a null state. From this node, similarly, if I see a 0, I cannot accept that string. Sorry, 0. Now, basically, for start state, I have transitions defined for 0, 1. For the intermediate nodes, again, I have transitions defined for 0 and 1 both. Now, let's come to the ending state. In ending state, if you see a 0, what you should do?
Again going to null state.
Which state?
Null state.
Okay, our friend is saying let's go to null state. Now let me draw null state. We'll see if it is correct in some time. Okay. Yeah, but nonetheless, please tell me like your views from end state. You see a 0, you go to null state, and if you see a 1, what will you do from this end state?
So we will stay at the end state.
You will stay at the end state if you see a 1. Okay. Now let's come to this end state. If you see a 0, what will you do from this end state?
No, sir. I mean, I
No,
think
no. Let's complete the DFA. I understand why you're saying no, but let's complete the transitions. Then we'll analyze what is wrong with this DFA. Then we'll
anything
correct it.
anything more than 0 or 1, we should go to for the next state, because otherwise more string will be accepted for this.
Okay, you are saying we should not have 0, 1 here. You should only have 1 here. Is it?
Yeah.
Okay. So then, are you saying then can I draw an arrow from this end state also to null state for 0, comma 1? Okay, so now our friends have proposed a DFA. Now, does anybody have objection with respect to this DFA?
Yes, I
Yeah,
have, sir.
yeah,
Basically, we will also have a string like 0011.
exactly, exactly. So, so this language, this regular expression, what it says is, you can take action A or action B 0 or more times, right? Now, let me enumerate some strings of this language. Let me do it here. If you take action A one time, then you will get the string A. Sorry, 00. You will get the string 00, 00. Like action A one time means you will get the set of strings 00, 000, 0000, etc. Are people convinced with action A being taken one time? Now, what would happen if I take action A two times?
So how can you accept 4 zeros with this string?
4 zeros, yeah. Action A. Now, this thing is 000 star, right? This 0 star means you can accept 0 or more zeros,
Okay.
right? You can accept 00, you can accept 000, you can accept 4 zeros, 5 zeros, anything, right? Now let us see what will happen if you take action A two times. Can you tell me the strings that occur when you take action A two times?
And 1110.
No, I'm telling action A two times. Action A is 000 star here, according to our naming convention.
It will
Can,
be 000.
yeah, 00.
Again 20.
Exactly. So you will the action A two times will correspond to 4 zeros or 5 zeros or 6 zeros, etc. Right? Now this is a plus operation here. This means that you can take action A or action B 0 or more times, which means this is also allowed. This kind of combination is also allowed. Action A one time, action B one time. This is also a valid combination, right?
Yes, sir.
Yeah. Can people tell me what are the strings that you will accept when you take action A one time followed by action B one time?
0011,
Exactly. 0011. Then
00011.
00011. And you can also accept 00011,
Yes.
00111, etc. You get the point, right? Do you see the point?
Yes, yes.
Now,
Yes.
this DFA is wrong because this DFA accepts epsilon. This DFA accepts 00. This DFA accepts 11. But this does not accept 000. What is happening? You see a 0, you go to intermediate state. Again, you see a 0, you go to end state. But because of this arrow, on seeing a third 0, you are going to a dead state, which is wrong. Right? Can somebody suggest a fix to that? So what I'm saying is
Sir,
on
we
this.
can look over the
Very
in
good,
this
very
step.
good, very good. So on this end state, if you see a 0, you will look
0.
over. Right? Now,
And then if I have 1, then I have to go for, for 1 and state.
yes, okay. Our friend is suggesting on seeing a 1, go to this end state. Is this
No,
what you're
sir.
suggesting? Now there is a problem with this. Now this DFA will start accepting string 001 also. But one thing you should notice here is corresponding to this one, there is no action. Our action is two or more ones. It is not one or more ones. Do you see why this transition is wrong?
Yes, sir,
Yes,
got it.
sir.
Yeah. So then, can you fix this transition for me?
Sir,
So we have
for
to,
one, it will transit to the next state,
Very
which
good.
is
To
from
this state,
start.
right? This state.
Yes, sir.
Now, similarly, can you fix the transition for this end state also?
Yes, sir. For one, it will loop over it, and for zero, it will go to the
Very good. So for one, it will
first.
loop over here, and for zero, it will go to this end state, this intermediate state. Now, I'll give you 2 minutes, right? I have drawn a DFA for this question. If you have a paper, just check if this DFA accepts only the strings that belong to this language. This is the first thing that you will check. Second thing you will check is it should not accept any string that does not belong to this language. Just take 2 minutes.
so it
Check.
is accepting because
Yeah,
it is
yeah.
accepting
Just
like,
take 2 minutes. You can verify for 2 minutes. If you have an objection, please raise that. Okay. In the meantime, let me see. There are some new participants. Admit, okay. Just take 2 minutes and analyze the DFA that I have drawn. And with respect to this language, is it accepting all the strings that belong to this language? But more importantly, you should check this. This should not even accept one string that does not belong to this language.
so it is accepting single zero.
It is accepting single zero. Yeah. Can you tell me the transition, the path that will lead to a single zero being accepted?
I mean, the first state is a start state.
Hmm.
No, no, no.
No, right? Yeah. Okay. So I believe that people may not be able to come up with some objections. So are we all convinced that this is a good, valid DFA for the question?
Yes, sir. I think
Yeah.
so.
Then, so I think we are slowly running out of time. Maybe I'll give you some 2 minutes. Can you draw a DFA for this option, second question? 0, 1 or 1, 0 followed by 0, 1 or 1, 0 followed by 0, 1 or 1, 0. Let me write the DFA here. Um, 0, 1 or 1, 0 followed by 0, 1 or 1, 0 followed by 0, 1 or 1, 0. So I'll give you 2 minutes. Just see if you're able to draw a DFA for this question. After 2 minutes, I'll ask you your solution. We'll see if it is correct. Okay, so does somebody have a solution? Okay, I'll start drawing. You please guide me as I draw the DFA. Okay, so we'll start with a start state as usual. Now, on seeing a 0, we'll go to accept state. Firstly, answer this. So is start state and end state?
No, sir.
No. So, on seeing a 0, do I go to a end state?
No, sir.
No. I'll go to intermediate state. On seeing a 1, do I go to an end state?
Yes.
Yes, sir.
Oh, you will go to an end state. Why?
No. Because sir, there is three concurrent strings.
Exactly. So, as I told you, the hidden operators you should sort of think of it as dot, a concatenation, right? This language will accept 0 1 is
Three
one
times.
action, 1 0 is other action. You can take either 0 1 or 1 0. So when you don't have a star here, you can think of as 1 here. 1 means you should definitely take this action once, which means it is saying you should take 0 1 or 1 0 exactly once. You should take one of these two exactly once. You cannot take both, right?
Yes, sir.
Yeah. So now 0 1 completes my let's call this total tuple as, let's say, action A. Let's call this thing as action B and this thing as action C, right? Now for the action A, the DFA is either you can take 0 1 or you can take 1 0. This part will complete my action A. Now similarly, let me extend this DFA to kind of account for action B. Again, if I see a 0, I'll go to intermediate state. I see a 1, I come to intermediate state. Then or I can take, I see an action 1, so I take 1 and take a 0, I can come to this thing. So this will complete my action B. Now the last action that I have to take is again kind of same. So I see a 0 intermediate state, I see a 1, go to next state, then see a 1, this thing, and here 0. Now once I complete these three actions, only then I can see a end state. Right now, is this DFA complete?
No,
Why?
No, sir. We have.
because there are 1 and 0 two transitions, and not every state has
We have
both.
to make transition for
Exactly.
other
We need to
symbols.
make transition from every state, right? Now, what are the missing transitions from this middle node? You have a transition for 1, but you do not have transition for 0. On seeing a 0, where should this go?
Null state.
Null state, exactly. So again, here you have a transition for 0. On seeing a 1, you will go to null state. Similarly, you get the point, right? So again, for this intermediate state, again you will draw the missing. Sorry, you'll draw the missing transitions and go to null state. I hope this DFA is clear.
Yes, sir.
Yeah. So then, third question, please take it as homework problem. Okay. So I think we have 10 minutes left. Maybe pumping lemma may be too much to cover in the next 10 minutes. Perhaps I think it is a good idea to go to complement DFA and intersection DFA. If I cover pumping lemma, maybe it will be kind of too much for you also. I think that's a good. It is a good idea for me to skip the next two questions and go to this complement DFA.
So put it for the next session.
Next session, I am planning to start engineering mathematics. Or if you want me to cover pumping lemma, I can do that. Actually, I'm prepared with pumping lemma for today's session also.
Okay.
It totally depends on you. If you feel pumping lemma will help you, I'm totally in for covering that.
Sir, because the application of something is a bit confusing. So if you can explain the steps for a particular example, so it will.
Okay, so then we'll take pumping lemma next class. Okay.
Yes. Thank
Now I'm coming to complement DFA. Now, what is a complement? So have people heard the term complement somewhere?
So complement means that like the states which are accepted somewhere
Not with
between.
respect to DFA. In general, like what is a basic mathematical object where we have seen complement?
Opposite of something.
Exactly, opposite of something. But we define complement for a set, right? Sets. So let's assume my universe is, let's say, A comma B comma C comma D. This is my universal set, right? And if I give a set A equals, let's say, AB, what is A complement?
Sir, C and D.
Yeah, a set with the elements C and D, and where we define A complement is omega minus A, right? Omega is universal set. From this omega set, you will remove all the elements that are present in the set A, that will constitute A complement, right? And I wonder if you have seen complement in even basic structure. For example, Venn diagram, right? Let's say this represents a universe omega, and you can have a set A here. And so this is set A. You will represent set A using by shading all of A. Now, can people tell me how to solve, what is the Venn diagram representation for A complement?
Sir, all the non-shaded parts are the
Correct. All the non-shaded
complement.
parts. So the point is, for any mathematical object, a complement of it means an object that is everything but itself. Is the point clear?
Yes, sir.
Yeah. Now let us see what does it even mean for me to define complement of a language. Now I started this class with two simple examples. One is 0 plus 1 the whole star, and other is 0 plus 1 the whole plus. And for this we saw that for the first language, the strings that are acceptable is epsilon, 0, 1, 0, 0, 0, 1, etc., etc., right? And for 0 plus 1 the whole plus, we saw the strings that are accepted are, sorry, epsilon is not accepted, uh, 0, 1, etc., etc. Now every regular language corresponds to a set of strings admitted by the language, right? For example, 0 plus 1 the whole star admits this set of strings as part of its language. Similarly, 0 plus 1 the whole plus, this regular expression admits this set of strings as its language, right? Now, when I define complement for these mathematical objects, why I brought this up before defining it is, we had a notion of omega, omega the kind of the parent set, right? In Venn diagram, yeah, in Venn diagram, what is omega?
The whole set,
Exactly,
so whole,
exactly. So when defining complement for any mathematical object, you need to have a precise notion of omega, right? Now here I have defined two languages. Let's call it L1. Let's call it L2. And we had another language, right? I think we drew the DFA for this language. L3 equals 0, 0, 0 star plus 1, 1, 1 star the whole star. And for this language, we saw the set of strings that are admitted is epsilon, 0, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, etc., etc., right? Now, for all the languages that are regular, can we come up with a language that is analogous to omega? So what I'm asking is, so here I have written three regular expressions: 0 plus 1 the whole star, 0 plus 1 the whole plus, and you can write some other regular expression. For example, 0, 1 plus 1, 0 followed by 0, 1, 0, 1 plus 1, 0, etc. We saw the third language, right, today. So that was 0, 1 plus 1, 0 followed by 0, 1 plus 1, 0, and this will give us some strings as part of this language. Now, can I come up with a language whose set of strings that are admitted is a superset of any other regular language?
So context free.
No. I'm only talking about regular languages. Let's not go to context. So okay. So I let me get to the point. What I'm saying is, for example, this L1 here, I'm saying L1 is a superset of any regular language you make, where the symbols omega sigma equals 0 comma 1. Do people agree?
Yes, sir.
Right. So this L1 is a superset. Now let's fix L1 to be omega. Right. Now let us define complement. Given a language L, we define L complement to be the set of all the strings
Not acceptable by the first.
that is not acceptable by L1. That is right. L complement equal to set of strings not accepted by L. But how do you define the set of strings? The set of strings is nothing but L1 minus L. Do you see what I mean? So I just stated what you told me. L complement is set of strings that are not accepted by L. And further I am defining that set to be L1 minus L, where L1 equals 0 plus 1 the whole star.
But sir, I mean, if L, I mean, if we are minusing L from L1, then L should be accepted by L1.
No. Okay, so maybe let me take an example. Let us define L to be 0 plus 1 the whole plus, right? And for this language, let us find L complement. So the strings that is accepted by 0 plus 1 the whole plus is 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, etc. Right? Now, can people tell me what is L complement when L is 0 plus 1 the whole plus?
So here we can say that L minus,
Yeah,
L1
It's
minus L2.
epsilon.
epsilon, correct. So L complement will be only epsilon, right?
Yes.
What I'm claiming is this L complement is equal to L1. L1 is the language set of strings admitted by the language 0 plus 1 the whole star, right? All I'm saying is this L complement equals L1 minus L. Do you verify that?
Yes, sir.
Yeah. When you do set minus with respect to the strings admitted by L, I mean L2 from L1, you get this epsilon, right? So in some sense, when you define complement with respect to the DFA that has start state as end state, and for every symbol within the language, it will accept. This is the DFA that's analogous to omega, and with respect to this DFA, you will compute the complement. Is this concept clear?
Yes, sir.
So just see if you're able to digest this concept. I'll just give 1 minute. Just think over it. If you have some doubts, let me know. Then we'll see to construction of complement of DFA. Is there any doubt?
But if, this is for the single transition. This is
Yeah.
just because if we have 0, 1 or 1, 0,
Yeah.
like this kind of string, how can complement will be, through this graph? Because there is only one transition, and for
No,
0,
no.
1, we have to
Okay. Got your. I'm not asking you to construct a complement of this language. What I'm saying is, for you to be able to construct a complement of language, you should subtract the strings that are accepted by that language from the set of strings that is accepted by this DFA.
Okay.
Is it clear now?
Yes, sir.
Yeah. So maybe I'll just repeat in one line. So in general, a complement operation is defined as omega minus a, right? When you do set complement, you have omega defined to be the universal set. For example, when you do complement in a Venn diagram, the notion of omega is everything in the set, right? Now we are coming to defining complements for regular languages. For regular language, we again should define a notion of omega. What is that omega notion? So for regular languages, the omega notion is the set of strings that are accepted by this DFA. So this DFA only used to define the notion of omega. From this DFA, we will subtract the strings accepted by L to define L complement. So I hope I'm clear. Is there any? If there is any doubt, please let me know. I'll again repeat.
Sir, I have a confusion because this graph only have one transition.
Yes.
How can
Oh, no,
this
no. Okay,
expect
okay.
that?
I got it. I got it. So here I meant symbol, right? By symbol, I mean you should substitute every symbol in the language. So this should be 0, comma 1, both. Sorry.
So we are considering just space of 0 and 1, right?
Here I'm considering space of 0, comma 1. Now let me give you one other regular language. Let's say L equals to.
No, no. I was I was seeing this as you clearing some universal concepts for article for
No, no,
all.
no, no. Sorry, sorry. Yeah, yeah. This is this transition has edges with respect to every symbol that is defined in your language. If you consider a language that has symbol 0, comma 1, you will put 0, comma 1. If I give you another regular language, let's say A plus B plus C plus D dot into, let's say, A plus B, the whole star. Now, in this language, you see the symbols in the language are A, B, C, D. The omega DFA will be something like the start state is the end state, and you will define transitions for A, comma B, comma C, comma D, and you will accept everything. This will be the notion of omega for a regular language that has symbols A, B, C, D.
Okay.
Right? Now, construction of complement is very easy. Let's start with a simple example. Let's say 0 plus 1 the whole plus. So we saw the DFA corresponding to this is you have a start state. Then you say you take a transition from 0 comma on 0 comma 1. You go to an end state. In the end state, if you see 0 comma 1, you will still remain in end state only. Now you already answered that the complement of this regular language is only epsilon, right? Can people tell me to how to draw regular expression for a DFA that only accepts epsilon? I'll start with the start state. Is start state and end state?
Yes, sir.
End
With
state.
no transition. With a
Every
sunset.
state again. So every DFA with respect to every transition, you should have an arrow. So if I have a start state, then you should definitely define transitions with respect to 0, comma 1. But if you see a 0, comma 1, it will go to a dead state. Right? You cannot simply draw a DFA and leave it like this. For every state, we definitely need transitions with respect to 0, 1. Got it? So here to complete the DFA, what I will do, I will define transition with respect to 0, 1, take it to a dead state, and a dead state on seeing 0, 1, it will remain in dead state only. Okay.
Yes.
Now, can you compare these two DFAs? This is L, this is L complement. Now, can you see what is happening between these two DFAs?
Yes, sir. Basically, the start state of first one
Yes.
will becoming the end state of the second one, and the end state of the first one is becoming a dead state.
Yes. Start state becomes end state, and end state becomes dead state. So one thing I'll tell you, this dead state is something that I used to make the concepts easy. But in DFA, this state you need not designate this state as a dead state. So we I mark this as a dead state to kind of indicate that once you reach this state, no matter what you do, you cannot reach a end. You cannot reach a end state. I gave a special symbol to such states that will never lead you to a end state. I marked a phi here to say you consume some symbols, you arrived at a end state, you arrived at this state called phi. From this phi I'm using to indicate that once you reach this state, you cannot reach any other state, right? So if I kind of don't respect this designation called end state, I can make this algorithm as every end state will make it as non-end state. Okay, the observation you made is perfectly clear, I mean perfectly fine, but what I'm saying is in DFA we do not this end state is something that I use for convenience.
Okay, sir.
Yeah. Now let us see if this algorithm works for one other DFA that we saw today. For example, let me take this one, 0 1 plus 1 0
So
0
in
1 plus.
DFA we don't have such end states.
No, we do have end states, but it does not matter if you call them end states or not. End state is a special state that will not have paths to a terminal state or end state, right? For example, let me go to this DF. Okay, let me construct this DFA. I think with this the concept will be clear. So let us construct a DFA for 0 1 1 0 this thing. So we saw that DFA corresponding to this is, you'll start with a start state. You see a 0, you'll go to intermediate state, then you will come to 1 1 0 0 1 0. Sorry, let me complete this. 1 0, then 0 1 1 0, and we define transitions, right? So from let me use a different color. Okay, so from this thing, this one, and this node, this node, and this node, all of these go to end state, I told, right? For instance, this node, on seeing a 0, it will go to end state, right? And end state will stay in end state forever. This is a DFA that we constructed, right? Do you recall that this is a DFA that we constructed for this language, L?
Yes, yes, sir.
Yeah. So while constructing, I told that from intermediate arrows, any illegal transition will lead you to a dead state. So now I'm asking you a question: what is really differentiating between a dead state and an intermediate state?
Sir, it's like there is no transition from a dead state to another state.
So the dead state will not be part of the DFA exactly.
Yes, dead state is not part of DFA. That is right. More importantly, you can see I call this state as not a dead state, because from this state I at least have one transition that
So
will
we
lead
can,
me to a end state. But from a dead state, you do not have any paths that will take you to a end state. So in some sense, once you reach a intermediate state, you at least have some hope of reaching the end state. But once you hit a dead state, done. The string cannot be accepted. Do you see the point?
So,
Yes, sir.
Yeah. Now let us follow the algorithm that our friend told to kind of construct the complement of this language. Now for that, what we should do is to make the end state as not an end state, and every other not end state as end state. Right? And you will make dead state also as end state.
so then that is will be part of the DSA?
And for the complement languages, for the complement language.
No, sir. My suppose a gate question is like, they ask for a graph
Mhm.
where there is state is included, and they ask how many states will be there. So will we consider?
Oh, okay, okay. That question is kind of that question we did not cover. So when they ask how many states are part of a DFA, then implicitly they are asking how many states are part of a minimal DFA. We did
Okay.
not really cover the construction of a minimal DFA. What do I mean by minimal DFA? When I started with the class, I told yes, I told that this one, I told that yeah, this DFA and this DFA are kind of equivalent. I told for this language 0 plus 1 the whole star, both the DFAs are correct. But the one on the right hand side is a minimal DFA. Minimal DFA because it is representing the same language using the least possible states it can.
No, sir. Suppose they ask for maximum number of states possible in this kind of DFA,
No, no,
where
they
we
will not
have.
ask for maximal number of states. They will always ask for minimum number of states.
No, no. I just want to know for the concept, like, suppose they ask such questions,
For
then
maximal number of states.
yeah. So
Maximum
then,
number of states is infinity, right? For example, this DFA, you can always construct a maximal DFA with infinite states.
okay.
Do you want me to construct that?
No, thank you. I just when there is infinite number of states, so obviously there is no question should be
Yeah,
asked.
so a DFA will always have finite states. A DFA cannot have infinite states. When I say infinite, you can represent this language using a DFA with arbitrary number of states. But a DFA by definition cannot have infinite states.
Okay. So
Okay,
there should be not be in question like maximum number of states.
that's why this question is kind of illegal. They cannot ask maximal number of states in a DFA.
Okay, okay, thank
They always ask minimal number of states in a DFA. Okay, that question you'll never encounter maximal number of states. Okay.
thank
Now, now I think we followed the algorithm that our friend told to construct the complement of a DFA. Can people verify in your pen and paper that the DFA that I just drew here, whereby flipping the end state as not an end state and every other state as the end state? I claim that this is a complement. This DFA represents the complement of this language. Can you verify? Oh,
so
one
there
more
is
thing. Sorry, one more thing I
one.
should do is I should remove this transitions from 0 1. I should make it a self. Or as in what I could do is I should take so for earlier I had an end state, right? From that end state, um,
So I have a question.
yes.
Like, suppose the example you have shown. Suppose the same kind of question comes in gate, and they ask for how many end states in this complement. So should we consider this null state or invalid state as also as end
Yeah,
state?
so here I told that this is a valid DFA. Now to answer that how many end states that does a DFA has, then the implicit question is they're asking you the minimal number of like end states in the minimal DFA. Now we have to see if this null state is required in the minimal DFA.
So this is minimal, I feel, because there is a
Mhm.
concatenation, and you have to go for 3 times.
Oh, this minimal. Yeah, this I have to sit and verify if this is minimal. I'm not very sure the answer for this question. I just need to think if this is minimal. Okay. In particular, I need to see if this state is required. I mean, if I have to see if I can remove this state and still construct a DFA that represents complement of this language. That I'll verify, and perhaps we'll discuss this in the next class. Okay.
Okay.
Yeah. Now, maybe I think we are over time. So then, what I will do is to answer the question A. Remaining question, you please take it as homework. Okay. We'll just solve one more question, and perhaps we'll end the session. So now the question is, you have a language that does not contain the substring AB.
So E and F. I mean, if you can explain E and F.
E and F. Okay, sure. So okay, this question says, they are saying that they have given the complement of the language. The following language is a complement of a simpler language, meaning the question they have given L complement here, and they want you to find the regular expression for DFA for L. You understood the question, right? They have given L complement, they have asked you to find L, but it does not matter for us because L complements, the complement is L itself. Do you see what I mean?
Yes, sir.
Yeah. So should we start? Should we do E then?
Yes, sir.
Yeah. So E is set of all strings of the form W such that W is a string not in AB plus the whole star. Right? Now, for a moment, let's ignore this not in. Let's ignore this not in. Now, what I will do to kind of construct a DFA for this language, what I will do is let me construct the DFA for the language AB plus the whole star. Then I'll complement this using complement algorithm.
Yeah, got it.
Okay. Now, what is the DFA for AB plus?
So A. You can start with A. First transition
Yes, we'll start
with first transition A.
we'll start with A. Then
Next transition will be.
we'll see B. Then
So then this will be the accept state,
accept state. Yes.
and then first state will be accept state because there is a sign.
Right. So from the intermediate state, you define a transition for B. What will happen if you see A here?
First, for the start state have then second state will also be accept state.
You're saying this will be accept state.
Okay. Then
Just check if this is an accept state. So I understand the point of confusion. So when I draw DFAs, right, what I do is I understand the expression first. What I will do using like we had a systematic way of interpreting this expression AB plus the whole star. Let me interpret it, and I will draw DFA. If you follow this, the scope of confusion will be very less. Fine. AB plus the whole star. Let me first expand this operation. What is this saying? Accept
at least one B.
B one or more time. And the hidden operator here is concatenation. So this, when I expand this operation, then it says accept A followed by accept B one or more times, right? And then finally, when I interpret the whole expression, it says that I can accept this total action 0 or more times. Correct?
So is it equivalent to say AB star whole star? I mean,
Okay, you're saying AB star the whole star.
this is equivalent to this.
This is not equivalent because this irregular expression
No, I'm
represents.
not. I'm not saying AB star. I'm saying just AB whole star.
Oh, AB whole star. Ah, very good question. Yeah. Yeah, this is very good question. Let's see why AB the whole star is not equal to this language. What does this say as? This is saying accept A followed by B, and this entire action you can repeat 0 or more times. Now, you need to enumerate the language. You should again do like action. If you take action 0 times, that is this action. If you take 0 times, you will get epsilon. If you repeat this action 1 time, you will get AB. Now, what will happen if you repeat this action 2 times?
AB.
AB, AB,
AB, AB.
AB, AB. Right. Now, let us do the same exercise for this regular language. If you repeat 0 times, basically you will accept epsilon. If you repeat this action 1 time, you can accept the string AB, or you can accept the string ABB, or ABBB, etc., etc. Right? When you repeat this action 2 times, you can accept AB, AB, or you can accept ABB, AB, or you can accept AB, ABB, etc., etc. Now, I ask you a question. Does the second regular language, can this accept ABB, AB?
No.
No, right? That is why these two regular languages are not equal. Do you see the point?
Yes, sir.
Yeah. Now let's go to the question. So we are going to try to complement the regular language AB plus the whole star. Now,
There is one more question, sir. I mean, so it means that if I say A star into B star is different to saying AB whole star.
that's right. A star B star is different than AB star. Yes, that's right.
Thank you.
Yeah. So now when I draw DFA, I will draw one action at a time, right? So I have the language here. Maybe I will draw it here only. So I'm drawing the DFA here. Now what I'll do is, okay. What do I do to make the DFA accept strings of length 0? What I'll do immediately, I'll make a start state as end state. So I have accounted for strings of length 0, or strings of action taken 0 times, right? Now let me come to the strings of action taken 1 time. I should accept AB, ABB, etc., etc. Then what I'll do from this start state, I'll take a transition with respect to A, I'll go to intermediate state. Then I'll take a transition with respect to B, I'll go to a final state because AB is accepted. Once I accept a final state, I can accept any number of B's. Right? Now, this set of strings I have already accounted. Now, I will come to the strings corresponding to the action taken 2 times. I observe that AB is currently not accepted by my DFA. Then what I will do to make it accept AB from end state. So once I do AB, I will come to end state. From end state, when I see an A, I will come to intermediate state. Is it okay?
Yes.
Now I think I am almost done, but there are 2 transitions remaining. From start state, if you see a B, where would you go? Does my regular language accept B? No, right? It does not accept B.
It will be null state.
It will go to
And
null state, correct? So from A, if you see a B, you will go to null state. So null state, let me define by okay. Let me not use phi anymore because it may be confusing. I'm going to null state, right? Back of the mind, we know that this null state is phi, but let me not use symbol phi. Okay. So now from start state I have completed. You see a B, you go to null state. Now from the intermediate state you have a transition left with respect to A. On seeing AA, now I will ask a question. Does my regular language accept the string AA?
No.
No. Then on seeing A, I will immediately make it go to null state. And on null state, if you see AB, you will make it go to null state only.
Okay.
Is the DFA clear? Now the question is complement it. Now to complement it, I am simply going to follow the algorithm that my friend suggested. What I will do, I'll flip all the terminal states to be non-terminal states, and I'll flip all the non-terminal states to terminal states. Do I have a different color? Yeah. Let me use yellow here. I'll flip all the terminal states to, sorry, non-terminal states to terminal states.
So here we include that null state as well. Right?
We include null state also. Yes. Now just take 2 minutes to check if the DFA that I have drawn here accepts only the strings that are not accepted by AB plus. Can you verify?
Yes, sir.
Are you convinced that this is a valid complement DFA?
Because the strings are not accepted by this DFA, the previous string.
Correct. Okay. So I think maybe there are some confusion for complement. So in the next 5 minutes, I'll just repeat the complement logic, complement concept. Then we will break for today. Okay. So we started with the definition of a complement. Now we saw that in any mathematical operation that defines complement, we need to have a notion of universal set. For example, in set theory, the universal set is set of all objects, right? Now given a set A that contains subset of the universal set, you define the complement of the set to contain the objects that are not present in the set itself. So more precisely, we define A complement to be omega minus A. What does omega minus A mean? From the universal set, you will remove all the objects that are present in A, that will give you A complement. Now we again saw the semantics of complement in Venn diagram. In Venn diagram, basically the universal set represents a block where entire block is shaded. Now given a set A, omega A complement will be everything in omega but A. Right? Now the same concept of complement translates to regular languages also. Now, but for us to define complement of a regular language, we need to have some notion of omega. That is something that's analogous to universal set. Then we saw how to define the universal set. A universal set is a set that is defined by this DFA that contains just one state where the start state is the end state, and from this state you define transition with respect to every symbol in the language, and that transition will take you to the start state itself. Right? This is the notion of universal language. In with respect to regular languages, this is a notion of universal DFA. Now, what does a complement DFA mean? Or what does a complement of regular language mean? Right? Now, to understand that concept, we should know what are the strings that are accepted by the language. As an example, we saw a regular language 0 plus 1 the whole plus. This language admits the string 0, 1, 0, 1, 1, 0, etc. The strings that you see in the RHS as part of its language. Now to define the strings that are accepted by complement of L, what you will do is set subtraction. You will subtract the strings of this DFA. You will subtract the strings of this DFA from the strings accepted by this this language. So basically, uh, you'll take these set of strings epsilon 0 1 etc etc. From this set you will subtract these strings. That will give you the strings that are accepted by complement language. Now for the corresponding set of strings you need to design a DFA. Now once you understand the complement, what does the complement of regular language mean? The construction of DFA is very easy. What you will do is, given L, you will construct the DFA. To obtain L complement, you will simply follow two steps. What you will do? Uh, Sorry, I think this step is wrong. Somebody told me start state is end state, is it? Yeah, this step is wrong. Sorry. The complementation algorithm has only two steps. One, you will make end state as not an end state, and not an end state as end state. You will not make start state as end state. Is it clear? Like what I say? You will not make start state as end state. The only two steps in the algorithm is you will flip the end state to be not an end state. You will flip not an end state to be end state.
So
Okay.
when there are two states only, then for start state and end state, then not
No.
even.
Start state is a designated state where you have an arrow and you do not have a predecessor. That is a start state.
Okay.
Okay. Now what I'm saying is in the complementation algorithm, if the start state is originally a end state also, in the complement DFA, this end state will be not an end state. Like we saw in the DFA here. Yeah. The algorithm only involves flipping a terminal state to a non-terminal state. By terminal I mean end state. An end state to not an end state, and not an end state to an end state. That is the only two steps that is involved in the algorithm. Okay.
Yes, sir.
Yeah. So maybe we'll take next 2 minutes and maybe to make this concept clear, let us take one more example and conclude the session. So yeah, let us take this BA example now.
So, sir, I have a question that
Yeah.
suppose there is a DFA with only single state,
Yes.
and that is also end state.
Yes.
So, if we want to have a complement of it, then there will be no end state.
There will be no end state, correct. This DFA does not accept anything. It will not even accept epsilon.
Okay. Thank you.
Fine. Now let us take the symbols in the language are a comma b, and L is nothing but any string that contains BA. Can you draw a DFA corresponding? First step you need to draw DFA for L. Then you need to convert this DFA into DFA for L complement. Can you do that? It is very easy. So just you should be able to do it in 2 minutes.
Yes, sir, it can be done.
Yeah. Can you tell me the DFA? First, can you tell me the DFA for L?
So BA, so you have to first transition is B, then A, then the next for B we have to go back.
Yeah. Is this a valid DFA?
Yes, sir. It is valid.
No. But we have many missing transitions, right?
Yeah.
Now, what shall we do? Okay.
first,
Sorry, go ahead.
Sir, for the starting state, we can loop over for A's.
Correct, correct. Very good. So you loop over for A. Once you see a B, you will go to the next state. And if you see a B here, what you will do? You will again loop over. Am I right?
sir, but then loop is in
Yeah,
the
this is
previous
wrong.
state.
Correct. This transition is wrong. So what will you do if you see a B here?
So because the string is starting from B, so for A we have to go to null state.
No, 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 no. So I'm saying this contains, right? Contains mean okay. The languages, the strings that are accepted by languages,
Right, got it,
B
got it.
A B A. It can accept A B A also, A B A B A B A also,
Okay.
A B A B A also, because this string also contains B A B A, right? So
So if we get next for if we have A, then we have to go back to the first state.
exactly, very good. So you will go to start state from for A. Now on seeing A, you came here. Now here, if you see a B, where will you go?
So we have to think about B, right?
Yes.
Because
So
already
I'm
have B.
talking about, I'm talking about this arrow. On from this node, once you see a B, sorry, once you see a, where will you go? B already you have defined. Once you see an A,
Sir, but prior to that state, we have already defined transition for A.
where? Okay,
The
let
state
me
just
number the
after A.
states. Let's call this state S1. This is S2, S3, S4, S5. From S3 on seeing an A, where should I go?
So we can go the first state because we have to have BA.
Correct. You will go to first state.
Sir,
Then
for S2 state, we have two transitions for A.
sorry. Then this should be yeah,
Yes, sir.
that's right.
Yes,
Yeah, then from S2, if you see a B, you can loop over S2, right?
Yes, sir.
Yeah. Then from S4 on seeing a B, where shall we go?
to go S2 because
Very good. We should go to S2. I thought you will be confused and say we should go to S1. You're right. We should go to S2. Thank you. Like this is the right transition. Then from S5 on seeing A or B, where should we go?
we have to loop over
Very good.
because
Very good.
we don't care.
A comma B. Very good. Right. This is the DFA that accepts L. Now let us construct a DFA that accepts L complement. So to avoid clutter, let me draw this states again. This is S1. This is
So we simply have to change all the other state as accepted and accepted as a non-accepted.
correct. That is what we'll do. So all the non-terminal states will be terminal. So S5 will be non-terminal now. Remaining all states will be terminal states, and arrows remain as it is. Right? On seeing an A, you will stay here. This will be B. This will be B, A, B, A, A comma B. On B, you go to S2. From S3, on seeing an A, you go to S1. Now, just to kind of confirm the validity of our algorithm, just verify that this language will accept all possible strings except the ones that contains BA as a substring in it. So, for example, it accepts epsilon, it accepts it accepts AA. But the moment the string contains BA, we go to a end state. Once you reach a end state, no matter what you see, you continue to stay in the end state only.
Yes.
That is why this L complement does not accept any string that contains BAB as a substring. Okay.
Yes, sir.
Okay, then. So I think this is enough for today. So if you have any doubts, please let me know. Otherwise, we'll conclude the session.
So, no, sir, I don't have doubt, but sir, there are two things I need to get more explanation for: inverse language and that pumping lemma.
Okay, pumping lemma will take it up next class. But I think pumping lemma alone will require 1 hour for me. So next class we'll only see pumping lemma. What is inverse language?
So just when we say 1 by L, or
Oh, what is 1 by L?
divide of, yeah, when divide, there is a concept of,
I'm not aware of what is an inverse language. Let me just check. You're saying inverse of a regular language.
yeah.
This looks like maybe advanced concept. I don't think this is part of GATE syllabus. They're discussing homomorphisms. So
It comes in great syllabus, perhaps.
actually, yeah. One more request is if you can populate the questions with GATE questions, no, it will be easy for me to prepare. So
Okay.
this time what happened that I got to know the questions only today evening, and as I told, like when I solved the question, I made a lot of silly mistakes. I think even in the class when I solved it real time, I made a lot of silly mistakes because this TOC is not my area of expertise. I am into data science and machine learning, so probability, linear algebra, engineering mathematics are my very strong subjects. You know, so I am okay teaching TOC if that is what the class wants, but at least I need 1 day for me to prepare because I should consult other people who are experts in this domain to kind of make sure that whatever I solve is correct.
Okay.
Yeah.
So will you take a class for algorithm and analysis of algorithm?
Yeah, that is a problem because for GATE computer science, manpower is very less. I am the only person, and my commitment to this NPTEL effort is only one hour per week.
Okay.
Yeah, so
So you will basically focus on engineering mathematics.
yeah, because that is my strong subject, no. And one more thing, what I felt was when I looked through material online, you have lots of teaching material for core courses.
Yes.
But engineering mathematics, I think that is one thing we do not have enough material because the subject itself is vast. But for GATE, actually, if you prepare strategically, you can score marks in mathematics also. That is
Yes.
why I thought perhaps it is best for me to teach my expert subjects. I mean subjects that I have expertise in, and also cover subjects that are not very dominantly covered outside.
Okay.
But if the total class is interested in TOC, I can do this as well.
So you can have any other session, like if you are interested in having a linear algebra session for next week, you can have that.
Yes.
Actually, I have few confusions in like operating system, like um, and then so I just need to discuss these things.
Yeah, but I can take it only one topic at a time because I need also to come prepared to the session, right? So
Okay,
yeah,
no problem.
yeah, yeah. Inverse language even I have not never. I think I don't remember. Yeah, yeah. Maybe I'll look over it. Yeah, I'll look over it next time then when I come.
So I say that you said that you're not comfortable in TOC, so I mean this next section have all the things of TOC, then when you can move on to linear algebra and engineering mathematics.
Sure, sure, sure. Yes, makes sense. So then next class, what shall we go over matrices and determinants?
Okay.
Yeah. So for questions, I think if you can give me GATE questions, right, that will really help you also.
Okay, so I need that.
Yeah. Yeah. Okay, Nishik. And I think you can populate these GATE questions only. I'm okay to for when it comes to engineering mathematics, I'm okay to solving any question, not just GATE questions. But if you stick to GATE questions, it will help you because we can stay focused.
Okay, sir. I mean, I have shared the questions in standard books.
Yes,
It's
yes. No, these questions are really good because by solving this question, I think you get a complete overview of regular language and finite automata. I think this covers breadth and depth of this concept. These questions
Yeah.
are indeed very good. But like the way you're asking inverse language, right? I'm not sure if any gate question asked inverse language so far. Because if they had asked, I'm quite sure that I should remember it now. Because I prepared for GATE in 2015. Until 2015, I don't think I saw a question on inverse language. I'm not very sure though. I have to check.
Okay.
You know, so if you stick to GATE questions, I think that will keep a check on the syllabus also.
Okay.
So should we go to linear algebra next session?
Yes, sir.
Yeah.
So,
Then yeah. Sorry.
will you cover pumping lemma in next session or not?
If you want me to cover pumping lemma, we'll take only pumping lemma next session.
Okay.
Okay. Then so for next session, I'll keep it as pumping lemma. So what is the date for next Friday? 2nd September, right?
Okay. So there are two pumping lemmas for linear language and context-free language. If you can cover both,
Okay.
if
Sure.
it's comfortable for you.
Sure. One request will be, can you populate some questions with respect to these two concepts?
Okay, sir. I will. Sir.
Yeah, I think we have some question already. Like I am prepared for these questions.
Yes, sir. There is one question for pumping lemma.
Yes, these questions are for pumping lemma that proves that a language is not regular.
Yes, sir.
You know, so I think these questions will be enough for first pumping lemma. For second pumping lemma, can you similarly, like populate the questions?
Yes, sir.
Okay.
Yes, sir.
Yeah. Okay, Rashima. Thank you so much.
So share your link, channel link.
Oh, channel link. Yeah, I need to see how to upload. So how do I share it?
I mean, you can create a channel of your own, and then you can share them. Then you'll upload at later.
Let me know. Let me log into YouTube. Let me know. Like, so they told me to upload in my YouTube channel.
Yes, sir. Normally, in NPTEL classes, the teaching assistant upload in their respective channels.
Yeah, respective channel. Right. So should I share the link of this thing? Okay. Yeah. This is the channel. Yeah. This is my YouTube channel. Right. I'm sharing it here. I'll upload it right now. Yeah. So please make a note of this link. I think once we end the meet, this link will go away. Or perhaps it's a good idea for me to copy this into the Excel sheet here. So I'm copying it here also. Okay.
Yes.
Okay then. Thank you so much.
Okay. Thank you.
Thank you, sir.
Yeah. Bye.
Thank you, sir.
Yeah. Bye.
Thank you, sir.
Yeah. Thank you. Bye.